Good day to you. This is teacher Leland, Alejandro, and we're going to study now how to compute missing parts in a parallelogram. So we're going to solve problems about parallelograms with missing angles or missing lengths or missing diagonals. So let's see the problem set in the other screen. Okay, here's the worksheet, parallelograms, and this about around 12 numbers. Okay, 12 numbers. Okay, let's solve one by one. Check on the first number. Okay, here's the first number, and instruction is find the measurement indicated in each parallelogram. All right, so for number one, we have find the measure of angle U. Okay, the measure of angle U. So you can see the figure over here. We can shrink it a little bit so we will have more space to write on. Okay, so that looks like appropriate already. We're looking for the angle U. So let us locate that in the diagram. So it must be this one. The measure of the angle U. Okay, the other angle is the angle T. Now, these two are consecutive, okay? So consecutive. Now, in parallelograms, it's a characteristic of parallelogram that two consecutive angles are supplementary, okay? Meaning the sum is 180. So we can set up the equation. Let us solve for the x first, okay? So for our solution, we can set up like the measure of angle U plus the measure of angle T, okay? So it's angle U plus angle T. That's letter T, okay. Angle U plus angle T must be equal to 180, okay? This will be in words, okay? Angle U plus angle T is equal to 180. Okay, so direct substitution, let's get the equivalent expressions. Angle U is 9x plus 12. So we have 9x plus 12 plus the 6x minus 12. 6x minus 12. This must be equal to 180. This is our working equation. Okay, so we're going to solve this. 9x and 6x gives us 15x. And the two 12s, the number 12 positive and the number 12 negative cancels out to 0. So this is just equal to 180. Okay, so we're going to have the next line, which is division. 15x equals 180. We're going to divide this by 15, and we're going to divide the other by 15. So this will have a division symbol over here and a division symbol over there. Okay, all right, so we have something like 180. We divide this by 15, so we have something like 30, and that should be 12. Okay, so our x is 12. Okay, after obtaining the x, we can now use this value to solve for angle U. Angle U measures equivalent to 9x plus 12. Okay, so this will be for the measurement of angle U. So the measure of angle U, so this is now capital U, all right? This will now be 9x plus 12, okay? And this will be 9 times our x, which is 12, and then plus 12, okay? Like this, there. So this will be about 9, 12, and then 1, 12. That means 10 times 12, okay? This must be about 120. So our angle U, this must be equal to 120 degrees. There. Okay, so this is our answer. Our answer is 120 degrees. All right, let's check and verify. Yes, it's over here. You can see the answer beside it. Okay. over here. It is displayed over there, okay? So the computer can display it there, okay? All right, there. All right. And so the answer is 120 degrees for number one. Let's consider the next figure. How about number two? Okay, here's number two. Find the measurement indicated in each parallelogram. Find the measure of angle W, okay? All right, so let us analyze the parallelogram. So we have the given angles, okay? Let us put the expressions in there. That's one angle and that's the other angle. So angle Y is expressed -3 plus 11x, and angle Z is 16x minus 6. These two angles expressed in algebraic expressions, when added, equals 180 because they are supplementary. The angles in a parallelogram, the opposite angles are equal, okay? But consecutive angles are supplementary. So we can actually add these two angles and equate this to 180. So our working equation, let us start with, okay, the angle Y, okay, angle Y plus angle Z must be equal to 180, okay? There, they are supplementary. And we can now use the expressions in the diagram. So we have -3 plus 11x plus 16x minus 6. This must be equal to 180 there. And then solving the equation, we have something like the numbers first. We have -9 for the -3 and -6. So we have a -9, and then we will add the 11x and the 16x. That will give us 27. 27x is equal to 180. Okay, so by way of addition, we will add 9 to both sides. So we will have here +9, and we have here +9. Okay, this number 9 cancels out to 0. We only have just 27x, and this is equal to 189 there. Okay, so we're going to divide both sides by 27, dividing both sides by 27 there, and we put a division line over here and a division line over there, okay? All right, so 189 divided by 27, so that looks like 7, yes. 189 divided by 27, so we have 49 and 4. That looks like 189, yes, okay? And so our x is 7. All right, we get the value of x. And we can now use the x to solve for the angles. Okay, we know that for a parallelogram, opposite angles are equal. So if we will solve y, that should be equal to the measure of angle W. Okay, over here, there. So we only need to get the value or the measure of angle y. So let us solve for angle y. Okay, so we have angle y measure. This must be equal to -3 plus 11x. Okay, and we will now use the x. So this is -3 plus 11 times the x, which is 7. So this will be like -3 plus 77, which is equivalent to just 74 degrees. So this is equal to 74 degrees. Okay, this will be our answer. So our answer is 74 degrees. Okay, all right, that will be our answer. Okay, this is our answer. All right, and this will be for angle y, of course. So this is angle y. Okay, now angle y is equal to angle w. Okay, all right, so we can also indicate here angle W is equal to 74 degrees. Okay, this must be it. Let me enclose it. All right, there. And then let us verify it. Is it 74? Yes, okay, over here. Computer shows the answer over here. Okay, and that means angle W is 74. There, I can make it blink. All right, there. Okay, it's 74 degrees. So number 2, let's proceed to number 3. I'll clear the screen. Here's the third figure. All right, find the measurement indicated in each parallelogram. Find the measure of angle E. So from our diagram, this is the angle E. The other consecutive angle is over there. So that means angle F plus angle E. Again, this is supplementary. That means the sum is 180. So we will have our solution such that the angle F added to angle E must be equal to 180. There. This is our working equation. Substitute the expressions 6x plus 4. So we have 6x plus 4 added to 10x. This must be equal to 180. Solve for x first. So we will have here adding similar or like terms. We have 16x plus 4 equal to 180. By way of subtraction property, minus 4 and then minus 4. We will have the next line 16x equal to 176. Okay, so we're going to divide this. Divide by 16. So we will divide this by 16. Also divide this by 16. There, and we put the division symbol. This will now be divide and divide. Okay, so how much do we have there? That looks like 11. Okay, x is equal to 11. There. That's 17 by 16. It's 1. Okay, that is 1. Bring down 6, 16, and 16. That's 1. That looks like 11. Yes. So our x is 11. Okay. This is our x. All right. We're going to solve now for E. Okay. Angle E. So for angle E, this is 10x. And this means 10 times 11. And we have something like 110. So angle E is equal to 110 degrees. There. And this is the answer. Okay. Let's verify from the computer what is the measure of angle E. There, it's 110 over here. Okay. All right, there. Okay. All right. So let's continue with the next number 4. Clear the screen and then proceed to the fourth. All right. Here's number 4. Find the measurement indicated in each parallelogram. Find the measure of angle G. Okay. We're after this angle. There. What is the measure of this angle? Okay. What's the measure of angle G? Okay. How are we going to get the value of angle G? Okay. This angle F and this angle H are opposite angle pair. All right. So they are equal. So once we have the measurement of any of this, either F or H, then we can use it and subtract it from 180. Okay. Because angle G plus angle F is 180. So if we can only solve angle F, then we can find angle G. So this is like this one. Okay. angle F, all right, plus angle G is 180 there. So if you can solve for F, then angle F becomes a number, and the only unknown is the angle G there. Okay, so the first thing we can do is equate angle F and angle H. So that means we have angle F, this is equal to angle H there. And so we solve first for X, okay, and we will have our working equation. So this will be 23x minus 3. This must be equal to 3 plus 22x there. Okay, we shall do it by way of subtraction. This will be minus 22x. This will be minus 22x. From both sides, next line is just x. Minus 3 is equal to 3 there. And by way of addition, add 3 to both sides. Add 3, add 3 there. And we shall get the next line, x equal to 6. Okay, so x is equal to 6 there. Okay, so we know our x. We can now solve for our angle F. Okay, solve for angle F. Okay, and angle F is equal to 23x minus 3, and this is equal to 23 times 6, and then this is minus 3. Okay, and then that should be about 138 minus 3. So this is 138 minus 3. Okay, this is 138 minus 3, which gives us 135. Okay, so this is equal to 135 there. So our angle F is equal to 135 degrees. Okay, this is angle F. Okay, now angle G from here, from this equation over here. Angle F plus angle G equals 180. That means we have this equation. Okay, here's our next equation. All right, 135 plus angle G must be equal to 180. Okay, all right, and so we subtract 135 from both sides. So we will have minus 135 here and minus 135 there. And we have angle G. This must be equal to 45 degrees. There. So our answer is 45. Okay, that's our angle G. Okay, all right, let us verify. There's the answer over here. There is the answer. Okay, and we can make it blink there. That's 45 degrees. That's the computer's answer there. Okay, all right, so that's the way to obtain the unknown angle for the diagram number 4. So let's proceed to number 5. Let me clear the screen. And here's number 5. Okay, here's number 5. All right, here's number 5. Find the measurement indicated in each parallelogram. Find CD. This time we're not looking for angle. We're looking for a segment, a side. Okay. All right. So we're looking for this side over here. We're looking for this side here, there. So what is the measure of that red marked side? Okay. So this will be CD, and this must be equal to the opposite side BE. Okay, they are equal. So we can just equate this. We can have our working equation in our solution. So we can now use CD must be equal to BE. Let's use capital letters. CD must be equal to BE there. And so the expressions will be 2x plus 4, 2x 2x plus 4 must be equal to 4x minus 4. 4x minus 4. There. Okay. Okay. Solve for x first. We shall subtract the smaller x term. This will be minus 2x from both sides. And we get like 4 at the left side. And at the right side, we get 2x minus 4. And then next line is by way of adding 4. So we add 4 to the left, add 4 to the right. And we have like 8. Next line will be 8, and this is equal to 2x there. And so we will proceed by division. We will divide by 2, divide this by 2, and divide this by 2. And then we put the division symbol. This is 8 over 2. This is 2x over 2. And x is equal to 4. All right, this is 4 equals x. Or properly written, this is x equal to 4. This is the value of x. Now, we can now compute for CD. Okay, so we will now solve for CD. We have, all right, the equivalent for CD. CD is equal to 2x plus 4. So this must be equal to 2 times the value of x, which we found 4. And then we add 4 there. And this must be 8 plus 8 plus 4. That should be about 8 plus 4 is 12. So our CD is equivalent to 12 units. Okay, so this will be unit of length, of course. So CD is 12. Okay, CD is 12. Let me put it there. CD is equal to 12 units. All right, there. And this is our answer. All right, let us check and verify from the computer. There, it's 12. Okay, computer's answer is over here. There. Let's continue with number 6. Clear the screen and then proceed to number 6. Okay, here's number 6. Find the measurement indicated in each parallelogram. We're after GF. Find GF. It's this side. Let me mark it with a red. This side. Okay, this is GF. All right, so let's find the distance. Now, GF is equal to EH. So in our solution, this is GF is equal to EH, okay? EH, all right. And then we will write the working equation. So GF or FG is x plus 3. And this is equal to EH, that's 3x minus 3 there. So we solve the equation by way of subtraction. We have subtract x from both sides. Next line, we will have 3 at the left side. And this is equal to 2x minus 3 there. And so next line, we add 3. So we'll have plus 3 and plus 3 there. Okay, so at the left side, we will have 6. And the right side is 2x, just 2x. And then we will divide this by the 2 there. And then we put a division symbol. There's the division symbol there. And so x is equal to 3. We have here 3. This is equal to x, or properly written, x is equal to 3. Okay, so our x is equivalent to 3. We are now ready to solve for GF. Now the expression for GF is equal to x plus 3. So this is equal to our x is 3. We add 3. GF is 6. GF is 6 units. There. So our answer is 6. Okay, let's check it from the computer. There, it's 6. Okay. All right, that's the computer's answer. And here is our answer. There. All right, number 7 now. Let's continue with number 7. Here's number 7. Find the measurement indicated in the parallelogram. Find the VW segment or side. So VW is this side here. There. Okay, I marked it with a red color, red colored segment. So that's VW. Now this VW is equal to XU, the other side. Okay, opposite pairs of opposite sides in a parallelogram are congruent. They are. All right, so we can equate this, and our working equation. Let's start with our solution. We have VW must be equal to XU there. And our working equation is 2x minus 12 must be equal to x minus 1. There. Okay. This is our working equation. Solve for x first. So we subtract the smaller x. So we subtract x first, subtracting it from both sides. Next line will be 2x minus x is just x. Minus 12 is equal to negative 1. There. All right, next line we will have, okay, add 12 to both sides. And we add 12 here. And next line will be x is equal to just 11. All right, so this is the value of x. Okay, so we're not after the x here. We're after the measure of VW. So we will be using VW. This is now solve VW there. And VW is equal to 2x minus 12. And this is 2 times x. That means 2 times 11. And then minus 12. And we get like 22 minus 12. And this will be 10. Okay, so this will be just 10. So VW is equal to, let's put it in another line. VW is equal to 10 units. There. And this is our answer. All right. Let's check and verify from the computer. There, it's 10 units. Over here, the computer's answer. All right. Let's continue with the next. Let me clear the screen. Number 8 now. All right, here's number 8. Find the measurement indicated. Find TS. Okay, so where is TS first? TS is over here. So I'll mark it red. Okay, there. We're looking for that side. What's the measurement of that side? Now, TS is equal to RU. So our working equation will be equating these two sides. So this will be our solution. We will use TS must be equal to UR there. And our working equation must be like starting with TS, that's 2x plus 3. We will have 2x plus 3 must be equal to UR, which is 3x minus 7. 3x minus 7 there. Here's our working equation. We shall start by way of subtracting the smaller 2x minus 2x, okay? And then our next line will be, for the left side, we will only have 3. The right side, we will have now just x minus 7, there. And then next, we will now continue by way of addition property. We add 7, okay? We add 7 to both sides, and the left side will now be 10, and the right side is just x, there. And we finally have our x value set at 10, and we can now use this to compute for TS. Okay, compute now for TS. Solve TS. Okay, so this will now be TS is equal to the expression 2x plus 3. So direct substitution, this will be 2 times x means 2 times 10 plus 3. This must be about 23, okay? So this is TS, and this will become 20. We will add the 3, and TS is equal to 23 units. This is 23 units. All right, this is a unit of length. And is it 23? Okay, here's our answer. This is our answer. And now we will have to check and verify if it's 23. Yes, it's 23 over here. All right, as indicated by the computer, okay? All right, so we continue with number 9. Let's continue with number 9. All right, next, we will clear out the answer so that the computer will not display number 9, okay? All right, we clear it first. Let's continue with number 9. Okay, here's number 9. Find the measurement indicated in each parallelogram. This time we're looking for diagonals, okay? Now, the characteristic of parallelograms, diagonals, they bisect each other, okay? They bisect each other. So for, oh, it's prayer time. All right. I'll do that later. All right, so we have the parallelogram. The concept here we shall discuss first. Okay, a little bit. So let's draw a parallelogram. Okay, this is our parallelogram. Okay, now we have the diagonal there. Okay, now this diagonal is divided exactly by the other diagonal at the midpoint. Okay, so what do we mean by that? So this means this diagonal, okay, is divided into 2 equal parts there. Also, this part here is equal to this part. So the 2 diagonals divide each other, okay, exactly at their midpoints, okay. So they bisect each other, okay, to 2 congruent segments, okay. So we can easily make use of this characteristic in solving the parts of diagonals, okay. So this is a common midpoint, okay. This is a common midpoint. So just remember, for a parallelogram, this is actually a common midpoint. Okay. All right. They divide each other to 2 equal parts. All right. So that's it. And we can use this concept in solving the problems. So let me clear my explanations, and we will use the space for computation. All right. So what do we have for number 9? Find the measurement indicated. SF is equal to x minus 1. So where is SF first? Okay, SF is this. There. Okay. And then where is FQ? Okay, FQ is this. There. All right. The red and the blue segments are equal. They are, okay? Because they are divided by RT at point F. All right, so into 2 equal segments. All right, so we have SF given, we have FQ given, and they are equal. So our working equation will be equating this to segments. So we shall use in our solution. Okay, so we will use SF. This is equal to FQ there. Okay. All right, and so we can now use the equivalents. Our SF is x minus 1. Let me use a small letter x. This is equal to FQ, which is 2x minus 10. There. Okay, we solve for x first. We shall subtract the smaller x term. So this will be minus x. Let's move downwards. This is now minus x. This is minus x. And the left side becomes just minus 1. The right side is 2x minus x. That's 1x or simply x with a minus 10. Okay, the next line is we will add 10 to both sides. So this will be plus 10. And this will be plus 10. Okay. And the next line is 9. And this is equal to x. Okay. Or properly written, x first and followed by 9 there. And we found the value of x. Now we're asked to get SQ, okay? Not SF or FQ. It's SQ, which is the total, okay? We're after the total. So we're going to solve one of the segments, then double it. So we can have this particular working equation, okay? Solve for SQ, and SQ is equal to 2 times, all right, 2 times SF, okay, there. So we have here SQ is equal to 2 times, all right, the quantity SF. Our SF is x minus 1 there, okay. So this must be equal to 2 times the quantity. X is 9, so 9 minus 1. And we have something like 2 times 8, which gives us 16, okay? So our SQ is equal to 16 units. There, it's 16 units, okay? That's our answer. Let's show the answer from the computer. Let's shrink it because the answer is shown in our exactly where our writings. Let me shrink it there and remove the blue and the red. Okay, the blue and the red. Okay, and here's the answer. There. Okay, so this is the answer over here. There. Okay, so that should be 16 units, and that's exactly our answer. Number 10. Let's continue with number 10. Let me clear the screen. This is now number 10. Okay, let's enlarge it. Okay, there. Okay, so find the measurement indicated. Find mg. So if you analyze the problem, we have mg. So this is mg. There. Okay, and the other one is mk. All right, which one is mk? Mk is from here going there. Okay, that's mk. All right, so let us not put them together. Let me move the red. Let me move the red. Okay, there. Okay, so what we have is mg expression and mk. Mk is the entire diagonal. Okay, now mg is half of that. Okay, so we can have an equation like twice mg is mk. All right, So in our solution, we will have something like this. Let's put it somewhere lower because the answer will be displayed there later. Let's put it down here. All right. Okay, we have our working equation like mk, this is equal to 2 times mg. There. This will be our working equation. Okay. And now we will do a direct substitution. mk is -5 plus 3x. This is equal to 2 times mg. 2 times mg, which is x plus 1. There. Okay. All right. So mk is the entire length. mg is half of it. So we will just double it, and that will be equal to mk. All right. And now we shall solve for x first. So we have for the next line, -5 plus 3x is equal to 2x plus 2. Distributing the 2 to the x plus 1. And then for our next line, we shall subtract 2x from both sides. Okay, making the left side -5 plus x. And then the right side will just be a positive 2. Okay, so for the next line, we shall add 5 to both sides. There. And x is found. X is equal to 7. There. Okay, knowing the value of x, we can now solve for the unknown. Okay, we're after mg. Okay, we're after mg. So let's compute. Solve for mg. There. And mg is equal to x plus 1. All right. mg is equal to 7 plus 1. That means mg is equal to 8 units. There. This is our answer. We're after that particular segment, and we can verify the answer from the computer. There. It's 8. There. Okay. That's where the computer displays the answer. So we did not start typing there. All right, there. So it's 8 units, and that's exactly our computed value over here. So this must be correct there. Number 11, let's continue with 11. Let me clear the screen. Proceed to number 11. Here's number 11 diagram. Find the measurement indicated in the parallelogram. We have UD. So let us show UD first. This is UD. Okay. And where is DW? Okay, DW is over here. All right, it will be from here going there. Okay. All right, so we have the two parts of the entire diagonal, and that means they're equal. Okay, they are equal. So we can, all right, proceed to our solution. These two segments given are equal. So in our solution, they are UD must be equal to DW there. Okay, and so we shall be able to use the expressions 3x minus 6. So we have 3x minus 6 must be equal to x plus 14 there. And so the next line we shall subtract the smaller x like that. And the left side will be 2x minus 6 equal to 14. And then we continue by way of addition. We add 6. And we get like 2x is equal to 20. And then we proceed by division. So we divide by 2, divide by 2. And then we put a division line there. Divide and divide. Okay, so we will have x equal to 10. There. Okay, solving now for the required. We're after UW, okay? So UW is the entire length of the diagonal, okay? So all we need to do is equate this to twice one of these segments. So solve for UW. Solve for UW, okay. And so we can use our working equation. UW must be equal to twice. Well, we can choose between UD or DW. Okay, let's select the simpler DW. So 2 times DW is equal to the entire UW. So this must be UW capitalized. This is equal to 2 times DW. All right, and the expression is x plus 14. X plus 14. Okay, so we shall continue with UW. This is equal to 2 times our x is 10. We add the 14. We continue like UW is equal to 2 times the quantity 24. And we have 48, okay? UW is equal to 48 units. There. That's the answer, okay? Our answer, of course. So we will verify if it's correct from the computer. There, over here, okay? You can see it blinking on the screen, okay? Near the W, okay? There is the answer from the computer. There. Okay, and that's it for number 11. Let's proceed to our last number. Let's proceed to number 12. Here's number 12. Okay, and find the measurement indicated. What we have is KC, and we can mark that. This is KC, all right, and CM. CM is the other part there, okay? I will mark it red. Okay, so this will be it. All right, we are going to use this. We have KC and CM, and they are exactly equal. So in our solution, we can start here. We will use KC, and that's equal to CM there. And then the expressions we have for KC is 2x plus 24. It's equal to CM, that's x plus 24 there. Okay, solve for x first. So we shall proceed by subtracting the smaller x, minus x, and then minus x. Our next line is 2x minus x. That will be 1x or simply x plus 24. And the right side is another 24. This should give us a 0 after subtracting 24 from both sides. Okay, so we subtract 24. We subtract 24. We get x equal to 0. There. Our x is 0. So we can now solve for KC. All right, over here. We have here like solve for KC. And KC is equivalent to 2x plus 24. Now our x is 0. So we will have something like this is 2 times 0 plus 24, which will give us 0 plus 24. KC is 24. This is 24 units. There, and this is our final answer. KC is 24. Let's check and verify. Is it 24? Yes, it's 24 over there. All right, so here's the answer. And that will be for our final number. I hope you were able to learn from the examples solving unknowns in a parallelogram. So this will be all for this hour. We'll see you later. God bless.